Assalamu alaikum. My name is Wajahat Kareem, and today I will be telling how to build a line following robot from scratch. So basically, first of all, what is our line following robot? A line following robot is an autonomous robot which is able to follow either a black or white line that is drawn on surface consisting of contrasting colors. It is designed to move automatically and follow the made plot line. The robot uses IR sensors to identify the line, thus assisting the robot to stay on track. The array of four sensors make its system precise and flexible. The robot is driven by DC motors to control the movement of wheels. The Arduino or digital logic design is used to implement algorithm to control such speeds of motors, steering a robot to control along the line smoothly. This project aims to implement the algorithm and control the movement of the robot by proper tuning of control parameters and thus achieve better performance. It is used in industries and small household applications, tour guides in museum, etc., and other similar applications.
Our next step to design robot is research and paperwork. We have two ways to design a line for a robot, digital logic design and Arduino. As our project requirement is that we should design robots using DLD and we have to use at least 4 IR sensors and we have to use 2 muxs for left and right motors. As we have multiple inputs from sensor, single output for each motor. So we have used 8 cross 1 multiplexers. Here our truth table which show this is our left motor, this is our central one, and this is our central two sensor, and this is our left sensor, sorry, and this is our right. And these are our two motors, left motors and right motors. And these are our 16 possible inputs through sensor, and these are our outputs for each motor. So we will move on to our gate logic, gate level implementation, which uses K maps and equations. This is our left motor equation, A bar D plus A bar C plus A bar B, and this is our gate circuit diagram. And then this is our right motor K map, which is this equation, CD bar plus VD bar plus AD bar, and this is our circuit diagram. Now we have rudimentary logic through our outputs of motors, and this is our left motor equation, this is our right motor equation. So we will use rudimentary logic instead of gate level implementation. So this is our possible circuit that we will design later. These are our two muxs and these are our four inputs and one permanent input, and this is our left motor and right motor in this now. So we'll move on to our Proteus file here. This is our Proteus file which shows we have two circuits, rudimentary logic multiplexer based circuit and gate level implementation. Both gives us same output but they have different kind of circuits. So this one has six AND gates, two 3 input OR gates, and two motors and four inputs. And they uses two NOT gates as well. And these circuits that we will use later in our experiment. It has two multiplexers, two motors, and one ground, and they are also commonly grounded. And these are our four cell headers, which are connected to these four IR sensors. And these all IR sensors are VCC and VCC common and ground common, and they are connected to our these four logic toggles. So here we have our rudimentary logic table. So we will implement it one by one here. After this, we will move on to our PCB layout. These are our two diodes connected here, and here we have two outputs for our two motors, and these are our two multiplexers and NAND gate IC, and these are our four cell headers here. So we have connected them through T40 wire, and at jumpers we have connected them with T30 wire, and here we have at least four jumpers and minimum as low as possible. Here we have jumpers because we have printing a single layer PCB. So we will have jumpers. Now we will move on to our hardware parts. Hardware, we have first bought the following components: 8x1 multiplexer, which are two quantities, and this is 100 rupees. NOT gate, robo base, IR sensors, DC motors, wires, PCB board, IC base, motor driver. This is our total budget 2720. So these are following in the pictorial form. These are IR sensor. This is our PCB board. This is our Vero board. This is our robot bed with two motors and two wheels. And next we have tires, and we have other components we have already discussed, muxs and not gate. And this is our motor driver. And this is breadboard for initial testing. These are our wires. This is our 6-volt battery. Components, we placed them on our breadboard, and we verified our logic by getting inputs from our IR sensor. Next, we have connected this to our motor driver to test our motors. Then for checking, we placed these sensors and our breadboard and motor driver on the robot base, so we can check through our breadboard before going to our PCB. We made a mini arena to check our logic and verify that our robot is working properly. Then we printed layout on page, and we ironed it and stepped this sticker to our PCB board, and we get this all our ink from our page stick to the PCB, and we will now move on. These are our some results. So as you can see, all of the ink transferred to PCB. Now we moved on to our etching process. For etching PCB, we used FeCl3 and mixed it with hot water, and then rinse it thoroughly, and then we put our PCB plate in this solution and wait for 8 to 10 minutes. After 8 to 10 minutes, we removed our PCB from the solution, and we got result as shown in the figure. So now you will see this in the form of photo here. Then we dropped the scotch brite to remove ink thoroughly. Then we started drilling holes in our PCB, and we got a drill of 0.2 mm and drill all holes to place components later. After drilling the holes, we placed all of our components and started soldering one by one all components, and then we will remove the extra wires from our PCB, and then we will start checking our continuity of the circuits so that we got a good PCB and all components are connected correctly, nothing, and there is no short circuit in our PCB. Then we started placing all our PCB components on the breadboard base. So as you can see, we have placed our components on PCB, and then we could connect PCB jumpers, etc. And then we connect this PCB to our other components of our robot, like motors and our sensors. Connecting all external components to PCB, we will place our IR sensor on this smart Vero board on the robot. After placing all the components and doing all the things, it's time for testing. In this first step, if the robot is not moving quite well and it's wobbling due to poor calibration of IR sensor, and we have put a sensor at the back for checking. We put a sensor at the back to just check that our logic is working fine. Then we will tune our IR sensors and check the widths between the sensor so that we will get our required and expected output. And now is our final testing. Now we have placed all our sensors on front and we have recalibrated them and fixed the distance between them, and now you can see the robot is wobbling less and moving quite efficiently, and we have a successful project here. Next, we will move on to our challenges we faced building this robot. First challenge was to make a rudimentary logic from truth table. We have made a right truth table, but our rudimentary logic was wrong. After revising out all the concepts previously, we made a rudimentary logic successfully, and then we confirmed it to our total circuit using two muxs and other circuit components. Then second thing was in hardware. In hardware, PCB printing and etching process was really very tough. In this process, we mostly lost our print on the page, not on our PCB. But after trying many times, we got our print right and we etched the PCB successfully. Then was the process of selecting the right components. Mostly we got the components which we were not able to use in our circuit, but we improvised our thinking and we got our new and right one component. Then the main problem was placement of the sensor and with calibration that we have tuned by experimenting one after another. Then there was a power issue as our battery was not charging, so it will lose charging very quickly. So instead we used our adapter directly to run our robot, and our project was successful. We saw many failures and we conquered these failures through proper teamwork, and we got our required project successfully and our robot is running successfully. Thank you for watching and Allah Hafiz.